this will be the second video for the rules of differentiation. So, which means that I'm going to introduce you the differentiation of a composite function. Okay, differentiations of a composite function. Okay, a composite function by chain rule, by using chain rule. Alright, so but I will teach you such that I apply the chain rule, but you never see what is actually happening. So you don't know what is chain rule, right? Maybe you don't know what is chain rule and what is composite function, right? So I will show you some examples. So for example, so if this is a composite function, means that let's say you have a function, you have a function of y to be fx. It's a function of any functions, so to the power of n, right? The n can be 1, can be 2, can be 3, can be 4, okay? Can be any power. So then, okay, I'm going to apply this chain rule here. This is the chain rule here. So the chain rule here means that I'm going to differentiate this. So I'm using chain rule, but I never actually really tell you what is the chain rule that I'm using. You're going to let a u for this function. You're going to let u for fx, represent fx. Then you're going to apply some chain rule. Alright, but I want to teach you another way, which is we directly apply the chain rule without letting something to be u or a function, or means that you represent a function by using another variable. So there are not a need. So now for this is very easy here. So you just bring down the n, right? You just bring down n just like usual, like you apply basic rule. So then the power you go and minus with 1. The power you minus with 1. So of course that is not that easy because this is not the x, right? It's a function, so you bring down the n, then you write back the n minus 1, then you differentiate the inside one. The third step here. So the first step is you bringing down the power. The first step is you bring down the power. It's the first step. Second step is the n, you go and minus 1, you copy back all these things. Then third step will be you differentiate the function inside there. Alright, I'm going to show you some example. What is the meaning of differentiation of a composite function by using chain rule? Alright, this will be the example here. So I'm going to apply the chain rule by using the chain rule to differentiate the composite function. Right? So you see how I do this, right? So very simple. The technique is very important here. So dy dx, according to the techniques there, okay, this is the power of 6. You're not going to expand this one to the power of 6. It's so tired. You can actually expand this one. It's a binomial expansion. You expand, later you apply basic rule. But that method is not efficient. So what I do is I'm using the chain rule. So what I do, I bring down the 6. This is the function. This is your fx now. Your fx. Alright, your fx. So I bring down the power 6. Then I copy back. The second step. The first step, I bring down the 6. Then I copy back all these things. 2x cubed plus 7. Then this one becomes 6 minus 1. You have 5. Right? N minus 1. 5. So fx you just copy back. Later, differentiate the inside one. Just don't look at everything here. Differentiate the inside one. So become 3 times 2. 3 times 2, 6. So x. 3 minus 1, you have 2. Right? 3 minus 1, you have 2. Okay. Then differentiate this constant, 7. So you have 0. Right? And then you have done. Right? You have applied the chain rule here. So you have 6. Now this is 6x to the power of 2, 6x to the power of 2, 6 times 6, you have 36x to the power of 2, and 2x cubed plus 7 to the power of 5. As simple as that. So I will give you more example. If you not understand this example, you go for the second example. You go for the third example. Alright, I will give you at least 4 examples. Alright. Second example for differentiation of a composite function by using chain rule. So as you see that this is a constant, right? This is a constant. So it's okay. As you can rewrite this thing to be 2 divided by 2x power of 2 plus with 3x to the power of 102. Right? It's to the power of 102. Right? So you can rewrite this thing to be 2, right? 2. As you bring this whole thing go up by index, so you know that 2x power of 2 plus with 3x, you bring up, you are getting negative 102, right? So you have to understand this one, negative 102. So then you can see that there's actually something like this form here. So this constant doesn't matter. This is just a constant, right? So if there's a constant, so then you apply the power rule as well. The first step, you bring down the n, copy back the fx, then the n you minus 1, then you differentiate the inside. So you got 3 steps here. So okay, I start differentiate, then I writing f prime x here. Fx, I write f prime x. If y, I write dy dx. So now I'm going to apply the rule. So first you bring down the power, so you have 2 multiply with negative 102, right? 2 multiply with negative 102. After that, second step, salin balik, copy back. Just copy this whole thing, and the power you have to go and subtract by 1, right? The power have to subtract by 1. So this is the second step. The third step is, look at this inside here. This is your fx, right? This is your fx here. So differentiate the fx. So differentiate the fx. So differentiate 2x squared. You have 4 to the power of x. 2 minus 1, you have 1, right? So plus with differentiate 3x. So you were getting 3. So this is the differential form. So now I rewrite in a very neat way. So 2, you have negative 1. So you have negative 4x plus 3, right? Negative 4x plus 3. So negative 1 over 2 minus 1, you will have negative 302, right? Negative 202, negative 302. So you understood that this will be negative 302. So it's negative, so I'm going to bring it down. Bring it down, become 2x to the power of 2 plus with 3x. Plus with 3x. The negative, when you bring down, you become positive 3 over 2. So this will be the answer for this example. So let's go for another example, and you do it as an exercise. Alright, the third example, you can try first. So you see that this is power of 3, right? You can expand, yes, you can expand this thing and you can apply basic rule, but it's just wasting of time, right? So you're going to apply this is a composite function, right? It's like this functions in a cubic function. So you can apply chain rule. So how is it? So very simple. If you see there is a power there, so y, but this must be a single function. There are no other function that multiply to this function. So then, if there is a function multiply this function, then we need to apply another rule we call product rule. So now this case is a single function to the power of 3, right? So then I'm going to apply this formula. So I'm going to bring the 3 down, and the 3 you bring it down, multiply with 1, then 4x to the power of 2 minus with 3 over x. Copy back, second step, then the 3 you minus 1, you're getting 2, right? So first step, second step, copy back, 3 minus 1, so you're getting 2. So now the inside function, the function fx, the inside function, you have 4x to the power of 2 minus with 3x to the power of negative 1, right? So you can write it somewhere so that it helps you to differentiate. So now you're going to differentiate this one. So you're going to differentiate this. So 4x squared, you have 2, 4, 8x. 2 minus 1, you have power 1, right? So this one, negative 3x to the power of negative 1. So negative 1 multiplied with negative 3. So you have positive 3, right? Positive 3x. And negative 1, you have to minus with 1. Minus with 1. So you have negative 2. So now you can rewrite back. So your dy dx, sorry, I have to write dy dx because I start differentiating, right? So you must write dy dx here. So your dy dx, the first order derivative will be 3. Okay, this one is power 1, right? So will be 8x plus with 3 x to the power of negative 2, which will be over with x to the power of 2, right? multiply with 4x to the power of 2 minus with 3 over x to the power of 2. So this will be the answer after I apply the chain rule. So let's go for another example. Alright, this will be another example. So okay, you can rewrite as you know that let's say you have a to the power of m and the root n, right? The n root of a to the power of m. You can rewrite this whole thing as am divided by n, right? So as I apply for this rule also, so it will become 4x to the power of 4 minus with 16x to the power of 2. This is your m and this is your root 2 over 3. So then you can see that this is also, you can apply the chain rule, right? So then you start differentiating. So bring down the power, you have 2 over 3, right? 2 over 3. So then you have 4x to the power of 4 minus with 16 over with x to the power of 2, right? As you know that you need to bring down the power and you copy back this thing. Then this one you minus 1, 2 over 3, you have to minus with 1, and you're differentiating the function inside. The function inside that is 4x power 4 minus with 16x to the power negative 2, right? X to the power negative 2. So be careful while you're doing all this algebra. So okay, now you start differentiating this function separately here. So differentiate this one, you have 16x to the power of 3, right? 4 times 4, 16. 4 minus 1, you have 3. So plus, why plus? Because negative 2 plus with, right? So it's negative 2 plus with, plus with 32, right? Because 2 times with 16, 32, and x to the power of negative 3, right? Because you have to minus 1 here. You bring it down, you positive 32, so x to the power of negative 1, so negative 3. So you have done, so you have 2 over 3, 2 over 3. Be careful while you simplify. And this whole thing I copy in front here, so it become 16x to the power of 3 plus with 32 divided by x to the power of 3, right? So then you have this. This one you will have 4x to the power of 4 minus 16x to the power of 2. 2 over 3 minus 1. 2 over 3 minus 3 over 3. So you will have negative 1 over 3, right? Negative 1 over 3. So either you can leave it this way or you can rewrite this in the you can rewrite this way. Means that 2 over 3 you have 16 x to the power of 3 plus with 32 divided by x cubed divided by, this is negative 103. So when you move it down, you have power of 103, right? So you have x power of negative 103, you bring it down, you become 1 over x to the power 103. As 103, you can rewrite as the cube root of x, right? So I can rewrite this thing to be the cube root of 4x to the power 4 minus with 16 x to the power of 2. That's the answer for, after I simplify, this will be your answer. Or you can just leave this as your answer. Okay, that's all of applying the chain rule to differentiate a composite function.